sorry. D3 is not isomorphic to Z6. Okay, so you can't just sort of bring this over the other side in a sense. It's not as simple as that. It doesn't work. All right, let's do the same kind of trick that we did here on a slightly bigger group. Instead of D3, let's go to D4. And you can probably see, you know, we're using these dihedral groups a lot, so you can understand why Barnard and co-author spent a whole chapter on talking about dihedral groups, because, you know, he uses them a lot in later chapters. All right, so let's try D4. That's our group we start with, and we order the elements of D4. Now it's a dihedral group, so a bit of revision here. What is the presentation of the dihedral group? Well, you give a list, a set of its generators. Well, for a dihedral group, you only have two, A and B. So if this is N, and you also have a list of relations, the properties that A and B have. So if this is N, A to power N is E, the unit. B squared is E, the unit. And ABA equals B, right? So you have three relations there, and those three plus the list of the generators, A and B, that's the presentation of the group. It's the description of the group. A presentation of group is a description of the group, of a certain form. Okay, so here you have members of the group, and they've been ordered in such a way that you get all these cosets appearing. Right? So here's our subgroup. We're going to divide D4 by H, right? And see if we get a result that looks isomorphic to a smaller group. So here's your subgroup H. Now look, this is a coset, right? It's a left coset of, it's AH. Right? You can just see that, right? A times that, okay? And this is the coset BH. Right? And this is the coset BAH. Okay? So we've listed in order of cosets now, and similarly down here. So that's the subgroup H, that's AH coset, and this is the BH coset, and this is the BAH coset. All right, so work out your table and put your entries in the group table in the form of B, some power, B and then A to some power. So always have your B's on the left-hand side, and to do that, you use the relations of the dihedral group. That can involve a bit of algebra. You've done that before. Anyway, you get your table, right? Takes a bit of work. Now, again, if you stand back, you'll notice like this is the same, and this is the same, and this is the same, this is the same, that's the same. It looks like this group here. Right? Now this is just an order 4 group. This is an order 8 group. Right? The subgroup we chose, from which we found all these cosets, was just EA squared. And that was our subgroup. And we divide that subgroup into D4. So it'd be like D4/H. Right? And what we get, this table here, it sort of has the format, it sort of looks like this. Now we've seen a group table like this before. It's V. Can you remember? V for vier. It's a German word, just means 4. Vier, that's V-I-E-R. German word meaning 4, the number 4. So the Viergruppe, the 4 group. And so this has the format of the 4 group. This is the group table of V, the Viergruppe. Okay? So it looks as though D4 divided by this subgroup, which is in fact of the form Z2, right? There's only one group isomorphic. Sorry, there's only one group type. There is only one group type that's of order 2. That's the cyclic group, because 2 is a prime number, right? And it's this one. Okay, so D4 divided by Z2 is isomorphic to this, V. Now we seem to be having a pattern here. We choose a subset, call it H, okay? And a group, it's a group. So this H is a subgroup, okay? And then think of it as a subset here, and then we find, then we go along the row and the column, the headers, if you like, and we write the members of the group in cosets. So this would be H, this would be BH, right? And here we did H, so AH, BH, BA, BAH, right? So we have a bunch of cosets here, similarly here. And when we do that, we get a group that, in terms of blocks like this, the blocks, if you look on the blocks as elements, you get a smaller group, right? So so we've got two examples now. So D3 divided by Z3 is isomorphic to Z2, and D4 divided by Z2 is isomorphic to V. Okay, so it looks as though the trick to doing this is to choose a subset, well, in fact a subgroup, and then write the rest of the elements in terms of cosets of that subgroup, and then go looking for these blocks that are isomorphic to some smaller group, like V or Z2. Okay, that's you're starting to get suspicious that that's the case. You be a research mathematician. You're sniffing around like Marcus de Sautoy, the Oxford pure mathematician. For him, pure mathematics is about searching for patterns, pattern searching. Right? Well, we're seeing certain things in common here, right? The subgroup H, the cosets, okay? But it doesn't work. Well, not entirely, right? So let's, here we chose the subset EA squared, right? And again, where I should put, this is still D4, sorry, D3. With size 6, so D3. All right, so let's choose a subgroup H that's EB. Right, that's a subgroup. This here is Z2. Okay, so again, continue the rest of the list of the elements in the group and put them in the form of cosets. So these two would be the coset AH, and these two would be the coset A squared H, right? Well, work out your table. Do all the algebra for D3 so that you get. Well, I haven't actually done it here. Still got B's on the right, but anyway, it's a mess, right? It doesn't come out like this at all. It's not neat at all. So how do you interpret that? We did not get this nice stuff. We didn't get that nice stuff or that nice stuff in these nice blocks at all. We just got a mess. Like this block, well, in odd places and split. So these ovals are all over the place. It's a mess, right? It doesn't work. So well, that's puzzling, Right? So what's going on? Why does this approach, getting a subgroup and then listing it in terms of cosets, why does it work in these two cases and fails here? Why is that? So are there some like extra conditions, something extra that we need to make it work? Like, what's the difference between this case and these two? What's special about this one that makes it fail, and yet the other two worked? So is it worthwhile keeping this idea of choosing a subset and then listing your elements of your group in the form of cosets? Is it worthwhile keeping that idea, but putting some kinds of restrictions on, well, maybe your subset in such a way that it does work? So you get this and this, and you don't get that. Maybe there's some special condition you need to put on your subset, your H, and that's the answer. And you'll show that in as we progress in this lecture. So the answer to this problem, why does that not work and the other two do work, is here the subgroup H does not have a certain property. Whereas in these two cases, the subgroup H does, right? And so for a lot of this lecture we'll be figuring out just what is that property that H has to have that allows division, effectively, allows you to find a quotient group. And if you don't have that property on H, your subset, from which you generate all the cosets, if that subset H does not have that property, can't divide, doesn't work. You can't find a quotient group. All right? Now, I'm going to go off at a tangent now for a little while because I need some new tools. Because if these elements here that form blocks, and these blocks become elements in a smaller group,